Okay, so this section here, we're going to look at just more curve sketching. So a couple things that we want to start getting more familiar with is the shapes of the curves and how they relate to the derivatives and second derivatives. So here are some tips. This little chart kind of shows you a few things where if it's curving up, okay, we know we have a positive first derivative. Okay, so these are both curving up. If the concavity is based on the second derivative, so in this case, it's concave up, okay? So the second derivative is positive, first derivative positive looks like this. First derivative positive, second derivative negative means it's concave down, so it looks like this. Okay, so here's the opposite. So the first derivative is being negative, so these are all sloping down. The second derivative is positive, so concave up, concave up. Second derivative is negative, so sloping up, concave down, sloping down, concave down. Okay, so these are some pieces that we want to start becoming more familiar with. So there is a first derivative test for mins and maxes, and what we basically do is use a slope chart. Okay, so we want to take a look at our slope chart here. If the first derivative is positive, then zero, then negative, we have our positive slope, we have our zero slope, and we have our negative slope going like this. So we have a maximum here. Okay, same thing here. For minimums, we have negative slope, zero slope to positive slope. There are slides. This one happens to be negative to negative, okay, but we could have positive to positive going the other way. We want to start connecting this to what is the graph. This is what the red represents a graph of the f of x function. Okay, so this represents the values of the slopes. But we can also take a look at the slope graph. So what does the slope graph look like of this? Okay, if I were to look at a slope graph where the y-axis actually represents the slope of the derivative, what would this derivative look like? Well, it would have a positive y-coordinate, 0, and then negative y-coordinate. So it's going to go through the x-axis in this angle, okay, sloping down. If we're talking about a minimum point, so that's a maximum. Maximum goes to the derivative goes to the x-axis in that way. For a max, it's the opposite, right? We have a negative slope, a negative y-coordinate. We have our 0 y-coordinate here, and then we go to our positive y-coordinate. So we go from negative 0 positive, negative 0 positive. So it's going to cut through the x-axis. The f of x, f prime function is going to cut through the x-axis in this direction, okay, sloping up. For something like this, if I were to graph this, we know that this is a negative slope, so it's below the x-axis. Okay, it hits 0 and it goes back to negative, so something like that. If it was going the other way, for example, if it slid through the x-axis like this, then it would be a shape where it goes from positive to 0 and stays positive. Okay, and this is what the derivative function looks like. Okay, this is what the f function would look like here. This is what the derivative function looks like for these